All right, so surface area, we just studied that for a week. That is a Math 2 content standard. Volume of these same three-dimensional shapes is how we wrap up the week. This is also of a Math 2 standard. So volume is the amount of space inside, and we're also going to go practice 4 different formulas for this today. So please go ahead and fill that out. Volume, the amount of space inside a solid. And then let's talk about what did we used to do with polygons, and then what we're now doing with three-dimensional solids, and there's similarities and differences. So the measure around the outside of a polygon, what's a polygon? A triangle, a rectangle, a parallelogram, etc. All those polygons we studied earlier, this was called the perimeter. Remember that a circle is not a polygon. It's not made up of line segments. And the perimeter of a circle is a circumference. So for these polygons, we call that perimeter, the distance around. Now, when we do solids, which is what we did earlier this week, this is called the surface area. Because it's a three-dimensional solid, the surface area is the distance around, measuring around the outside. So then what about measuring the space inside of a polygon? Well, that's called the area, like length times width. And these are two-dimensional figures. And so what's this new final measure of space inside of a solid? Our study today will be on volume. We're just doing the one study guide today, the 7.5 and the 7.5 quiz. There's going to be in-class time to finish that quiz. And then you guys, if you do the worksheet with me after that, then you will not have any additional homework this weekend. 3-day weekend. Don't come to school Monday. Well, it's virtual day usually anyways, but. Okay, so in a one-dimensional figure, the perimeter is the length, and we give that answer in units. In two-dimensional figures, the area is length times width, that's our measurement, and we give that as square units. So finally, we're to the ultimate level in 3 dimensions today. And so it's going to be length times width times the third dimension height. And this is going to be in cubic units. So this is just units. This is units squared, and this is cubic units, units to the power of 3. Okay. Obviously, V stands for the volume. B stands for the area of one base, like yesterday's or earlier this week, base area. And then H stands for the height. And they're actually giving us a picture here of the same prism we did the surface area of in our study guide earlier this week. Notice it's still a 3, 4, 5 triangle here at the base. There's base 1, and here's the other base. So a 3, 4, 5 right triangle is our base. This is called a prism. So there are 2 bases, and the height is 20. Using these numbers, we're going to go practice this formula. So again, I'm calling this volume for any prism, BH. And so let's go identifying the shape of the base. We see that that is a right triangle. And we know that the area of the base when it's a right triangle is just going to be 1/2 base times height. Sorry. And the base times height is 3 times 4, so half of 12 is 6 units. So just like we already figured out with surface area earlier this week, this area of that base is 6 units, half of that 12. And we noticed that the height was 20, so we just multiply that. The volume equals the base area times the height, and so we get 120 cubic units, units to the power of 3. I think volume problems are way easier than surface. Like usually people are going to fly through the quiz today compared to that surface area one that took us a little bit of time. Give me a signal if you still need more time on this, or if you got it, we'll go on. Okay, so let's do volume for any cylinder. I did the green formula already today. Let's go blue for cylinder. Obviously, V stands for volume. R stands for the radius of the base, and H stands for the height. Here's what my letters mean. And then looking at this picture, again, the exact same picture that we did with surface area earlier this week, we're now going to find the volume of this cylinder. So we notice that 9 is my radius right here. And so 9 squared, I'm taking the area of that base. 9 times 9 is 81 pi. And my height is 23. Can you guys take a minute, please, and use your calculators to find that? I'm going to call on one of you. Please do 81 times 23 on your calculator. It can be a phone calculator or Desmos, whatever you prefer, or a yellow calculator. $81 times 23. What did you get, Daniel? 1863? Like that? Perfect. Someone else confirm they got that? And then you guys don't forget the little pi. 1863 pi units cubed. Cubic units. So power of 3, we say cubed because it's 3-dimensional figure. Signal me if you need more time on that guy. All right, so volume equals the base times height. Prisms, the base area is the area of whatever polygon is on the base. Cylinders, it's the area of the circle. So that's the only difference. Sometimes your bases are different. So why does the same formula work for all prisms and cylinders? So the amount of space inside a prism is defined by its size of its base and its height. Measuring the volume is like measuring how many bases you need to stack on top of each other to get there. Let's take a minute. That one's pretty long to write that one out. The amount of space inside the prism is defined by its size. And so it's measuring how many bases we would need to stack to reach the top. One of your quizzes talked about horizontal cross sections. Picture slicing that cylinder and how many of those slices you would need. Signal me if you need more time on this. Just raise a little finger. Okay, cool. Keep going. Okay, so now instead of talking whole prisms, let's talk about pyramids, kind of like part of a cube, or cones, part of a cylinder. So these ones only have one base instead of two bases. And notice that the volume for a pyramid, and it kind of makes sense, is 1/3 of the normal volume of that prism. So I'm going to use purple for the pyramid formula. And again, V stands for volume. B stands for the area of that base. There's only one base this time, and H stands for the height. So we just have to remember when that shape looks smaller, it's 1/3 of its normal full prism size. So looking down here, we've got to get a base area of what looks like a square, right? 8 by 8. And then we need to multiply that by its height, and we're going to take 1/3 of that. Okay. So identify the shape of the base. We noticed it's a square, an 8 by 8 square, and 8 squared is 64 units. So my base so far, I've got a 64 unit square base. And my height is 9. Now, real quick, let's go back and look at which height they're talking about. Notice I'm not using the slant height. I'm talking about the height of the inside of that pyramid. So that height is 9. So please take a minute to grab your calculators and multiply 1/3 of 64 times 9. You could do 1/3 of 9 is 3, and 3 times 64. Whatever works for you. You can multiply in any order. Please take a minute to do this on your calculators and tell me what you got. 1/3 of 64 of 9. All right. What did you get, Mia? Did you say 192 like that? Cubic units. Perfect. So that's volume formula number 3 of 4. So we did volume of a prism. We did volume of a cylinder. Now we're doing volume of pyramid and cone. All right. Last one, the cone. And I'm going to go yellow for this one. And again, that cone is 1/3 of the normal cylinder. Just like the pyramid is 1/3 of the prism, the cone is 1/3 of the cylinder. You've got the volume for your V. You've got your R standing for that radius of the base, and H standing for the height of the cone. Same 3 variables as the regular cylinder. We're just taking 1/3 of that same formula. And so we see that this has a 9 radius and a 12 height. Notice I'm not using the slant height like I do in surface area. I'm using that internal altitude, that height. So here I go. 9 squared. We're at 81 pi units squared for that area of the base. Once I have that area of the base, I multiply that by the height. Please get me the pi answer, the exact answer in terms of pi. 1/3 of 81 times 12 pi. And this time, Jonathan, will you be our calculator? What do you get for 81 times 12 divided by 3? Good. And now do me a favor, take that 324 and multiply it times 3.14. It's going to be 1,000 something if you've done it correct. Great. And that's units cubed. So here's my decimal answer. I don't even need to round if I use just the 3.14. And here's my exact answer in terms of pi. All right, we're going to summarize this here coming up in our final part of the study guide. Okay. Here we go, filling in these words. Two solids have equal volumes if they have equal heights and equal cross-sectional areas. So go ahead and fill in heights and equal cross-sectional areas. And like we just mentioned, finding the volume of a pyramid is like finding 1/3 of the volume of a prism that has the same base and height. And finding the volume of cone is 1/3 of the volume of a cylinder. I think there's only one L. That has the same base and height. So literally the same formula, we just take 1/3 of it. That looks like a CE, but that's an SE. Better. All right, starting with this checkup next, we're going to start in the back with Matthias. Matthias, you're going to do number 1 with me. Let me see what color formulas I used. I think I went green, pink, blue, yellow. I want to go double check. So I went green, purple. I forgot about the purple. Okay, green, blue, purple, and then yellow. Trying to keep the colors the same here for the checkup. Okay, notice that they give us all of these. I need you to get out your 4 different color highlighters. We're going to do some examples. Oh, notice how they switched them up on me here. My green was the prism. Purple for pyramid. Yellow for cone. And blue for cylinder. So it doesn't matter which colors you choose, but go ahead and highlight in 4 different colors if you can. And let's go look at the examples of when we're going to use what. So starting with the first one, notice that these have 2 bases, so it's not a pyramid or a cone. And then I'm just looking to see if the base is a polygon, triangle, rectangle, or is the base a circle. So these ones all happen to be prisms. So please highlight number 1, 2, and 3 as the green formula, volume of a prism. And then we're going to write it out to get it ready. We have it right up here. The volume is equal to the area of the base, that's what that big B stands for, times the height. Volume is equal to the area of the base times the height. Volume is equal to the area of the big base times the height. So get that big volume formula ready. Those are all 3 prisms. Next, we're looking at cylinders. Cylinders are volume equals big base times height as well. This is our blue formula. Notice that some are slanted, some are upright, doesn't matter. Area of the big base times height. Area of the big base times height for all 3. All that's changing from the prism formula is I'm going to be doing area of a circle instead of area of a triangle or a rectangle or a square. Take a minute to highlight those as the same color as the cylinder formula that you chose from the page before. Please write out the V equals BH. 6 and 7, what do you guys think? Are those pyramids or cones? You got it. Those are cones. And so I go up and look at my yellow cone formula, 1/3 of B times H. Notice how much easier these formulas are than Monday's and Tuesday's stuff. Area of the base times the height, and then we're taking 1/3 of it. And just to be clear, another way of saying 1/3 of something, couldn't I also just write the formula like that? Whatever times whatever over 3, it's dividing by 3. That's what taking 1/3 of something is. Last two, we've got the pyramid. Looking up at my choices, the purple pyramid formula was also 1/3 of B times H. So literally it's 4 formulas. It's really only 2, and they're the same thing, but a third of it. So these formulas, nice and simple today compared to the crazy ones from Tuesday. Okay, so 1/3 of B times H is how we're going to end this off. Anything that has a triangle or a polygon or, as the base, that answer is just going to be a decimal answer. Anything that has a circular base is going to have a pi answer, an exact answer, and a decimal. All right, Matthias, we're finally ready. Let's go back up. And I just want to make sure, Matthias, Miguel? Okay, I'm trying to make sure I don't keep confusing you guys. All right, so for number 1, how many of us are there? Hang on. I think we're each going to do 2. Okay, so Matthias, you're going to do number 1 and 2 with me right now. So what is the area of my big base? This big B here is actually going to be this entire shaded bottom region. What do you think, Matthias? Okay, good. And then times the height. What's that going to be? I just want to make sure the height you used was 8. Okay, good. And so 117 times 8, you got 936. And what are my units? Great. And I'm changing my mind. We're going to do 1 of each and go back just so you get something different next time. Okay, I'm jumping over now then to Miguel. Miguel, number 2, area of my big base is going to be what times what? Okay, so this one, the base is actually the triangle, not the rectangle. And this is the part that gets, the other one was too, guys. Hang on. I see how you visualize this. We got to go back for a sec. There are 2 bases in prisms. I highlighted this wrong one here. Sorry. Starting again back with you, Matthias. Do you see how this and this are the bases, not the one that I originally highlighted? So we want that area formula to be 1/2 of base times height of that front triangle. Apologize for that. Here we go back. So 1/2, I hope you guys wrote in pencil and can erase that. I see some erasing going on. Of what's my base and height of those triangles? Good. And then times that height, which in this case is now going to be 9. So take a minute to multiply that and see how that answer changes. And what'd you get, Matthias? Yep, and that's exactly half of what we just got, because this is like, do you see how it's kind of like cutting the full prism in half of what we did? All right, thanks for making that adjustment. I'm now going back over to Miguel. Miguel, looking at it now as the triangular base, the front and the back. What would be half of what times what for that base? Great. And then your height of the full figure? Good. Comes from right there. Okay, take a minute to multiply that out, everybody, and then he'll read his answer that he gets. Great, and what are our units? Good. All right, now I'm going to move up to Mia, and then it's going to go then Jonathan, then Justin. So Mia, looking this time, our 2 bases are here and here. What is that area of that pink base? Yep, just 25. Good. And then what's your height? Another 5. It's a cube. And so what's your final answer? Good. And then did you say cubic units? I couldn't hear. All right. Now, Mia, that one was way too easy. So you're doing the next one too. You're a different one. And so look at number 4 and how we're now going to go to cylinder. So this time, same formula, base area of the base times the height, but your area of your base formula is different for a circle. So my base this time is a circular base here and here. So let me zoom in. All right, area of that bottom base, Mia, the base of a circle is pi r squared. So down here, what's my radius of that bottom base? And what is 6 squared going to give you eventually? Good. So this down here is going to become 36 pi. And then what's the height we're multiplying by? Good. So can you do 36 times 14 for us, Mia, and tell us what you get? Perfect. 504 pi cubic units is the exact answer. Can you now take the 504 and multiply it by 3.14 and tell us what you get? All right. Exact and decimal answers. All right. I'm moving up to Jonathan. Jonathan, same thing now. Notice they gave us a slant height here, like a fake out, and they gave us a real height over here. We're going to want to use the real height. Hang on one sec. I want to just show you something here. Okay, can I show you guys this one first? And then Jonathan, you're going to help me with the next one. Where we're going to get that base area first, that pi r squared. And then we're going to multiply it by the actual height of 9, not the slant height. So base area first, and then plugging in that base area to get that volume. So here we go. The base area is pi r squared. And our radius is 5, as you saw in that example. And it's going to be times a height of 9. So can you multiply this for me, please? Jonathan, what is 25 times 9? And then take that 225 and multiply it by 3.14. Perfect. All right, Justin, on yours, what's the radius in the picture, Justin? Good. So go ahead and put the pi 7 squared this time. Now the height of yours got cut off. Can everybody draw in this 14 that accidentally got cut off there in the copy? So Justin, drawing in that 14 right over here. Okay, and then multiplying it by that height. So Justin, can you do 49 times 14 for us and tell us what you get? Great, and that's units cubed. And then now do the 686 times 3.14 for us. Great. And don't forget the units cubed. Okay, I'm going to be all the way over to Daniel now. Daniel, you're going to be doing number 7 with me, where we're just taking a third of something. Anybody have questions on 4, 5, or 6? Again, I think you guys tend to do way better with volume than you do with surface area anyways. Today's quiz should be nice. All right, so first we want that same base area, Daniel. What's my radius so I could do my pi r squared? And then the height of that solid? Great. So 1/3 of 16 pi times 15. Can you first just do 16 times 15 for us? $240 pi, and we want 1/3 of that, so do 240 divided by 3. Good, 80 pi. And that's units cubed. That's my exact answer. Now do your 80 times 3.14 for me. All right, I'm back over to Matthias. Matthias, we're doing the same thing that Daniel just did. This time, what's your radius of that big base area? Good. And then what's your height of that picture? Good. Thanks for not getting faked out with the slant height. We want the center altitude or height. So 64 pi times 20. What is 64 times 20? And then divide that by 3. Ooh, not pretty. Let's just leave it as 1280 pi over 3. But now multiply 1280 times 3.14 and divide it by 3, and let's get the decimal answer. And don't forget that units cubed. And did you use pi button or 3.14? Oh, I think you forgot to divide it by 3. Did you do 1280 times pi and stop there? Okay, do one more step. Sorry, get out those erasers again. Okay, read me those numbers. And since we're rounding this time, there's that approximation symbol, guys. All right, we're going down to just a couple of pyramids, also 1/3 of the big area base times height. I'm going to go over to Miguel and then forward to Justin. Mia already did 2. Okay, and then because we're back, Miguel, to a rectangular base or a square base, a polygon base, we don't need that pi answer and that decimal answer. You're just going to get me a decimal answer. So 1/3 of the area of the big base. What's my area of the big base? Yep, 10 times 10, right? And then your height of the whole thing. Remember, there's a slant height and there's an interior height or altitude. Which one do you want to use? Good. So half of 20 times 14. 100 times 14. Yep. Oh, thank you, thank you. So the first one was right, just that one. Okay, good catch. And then 10 times 10 was 100 times 14. So 1/3 of that 1400, and tell us what you get. Good. And so we're going to go 0.67 to round, and then we're going to go cubic units. Put that approximation symbol because of the rounding. All right, Justin, last one. Just like we just did on number 9, we're going to do a third of that area of the square base. So what's the base going to be? What times what? We're not going to use that slant height. That slant height is for the surface area formulas only. We're going to do the area of the base, that square on the bottom that's right here and right here, Justin. Yep, just 4 by 4, and then times the interior height. Can you see it way inside there? If I ignore this for a sec. Yeah, just 7. So it's like they're putting that slant height there to fake you guys out. You don't need that for volume. You only need that for surface area. All right. Oh, I did it again. Look at that, Miguel. Just really excited about the 1/2. Okay, Justin, you're going to do 16 times 7 divided by 3 for us on your calculator. Good. And my units are cubic units. Excellent job, you guys. Okay. So we are now just going to take some independent time to do 2 things. You're going to turn in this right into the bin. And remember, when you're in person, you can just turn in the checkup. People at home are turning in all the pages to show me what they did. After you turn this in, you're going to open up and take the 7.5.3 quiz.